number 6, and this is going to be our presentation for phase 2 of the design project. Our team was tasked with the design of the trailer, the operator cab, the rope guide system, and the wheel cutter. And we were also, obviously, because we have a support system for the other teams, we had to work with each team to ensure that we could meet the overall winch design and safely launch safely. Our major requirements for the trailer, obviously a key component, we had to make sure that the loads from both our system and from the other ones were all supported appropriately. We had to have everything spaced correctly and make sure we did not see any towable weights. The operator cab needed to meet the previous requirements to keep the driver or the operator safe, and it also has to be able to house the control systems. Our rope guide system, we had to analyze to make sure that it could withstand the maximum force of experience and successfully guide our cable onto the spool. We had to design a cutter that was capable in an emergency, and we ended up designing a motor stand also. So we had to analyze that for loading as well. And as you can see here, the overall design, we just saw shared drawing. So we have our rope guide going on the spool, driven by the motor, powered by the batteries, controlled by the engine.
For the designs, the rope guide system was initially going to be mounted on the winch. However, after consideration, we decided to put on an independent stand for simplicity's sake. For the trailer, initially we wanted to increase the strength by increasing the bed thickness. However, because of cost, we increased the cross members instead. The cab was initially designed with an aluminum frame, but after we considered welding the frame, we decided to choose the steel design. For the engine stand, originally it was a box design. However, to accommodate the engine team, we decided to create an I-beam design for rigidity. The guillotine rope cutter initially was spring driven. However, because we have a hydraulic system in the trailer already, we're going to utilize that. And the cutter itself is a web tool softline cutter. The model is SL55. The cutting capacity can accommodate for up to a diameter of 55 millimeters. The weight is 10 kilograms and the maximum pressure is 210 bars.
The trailer we chose is a standard 16-foot car trailer, as it required minimal modifications, which consisted of adding more cross members for bed strength, 4 trailer stabilizers, 1 in each corner, and 2 double action hydraulic pistons for the anchoring system. We ran FEA load analysis on the bed to determine the stresses, displacements, and factor of safety, and all 3 of these were at the max directly under the spool assembly, and which gave a 7.4 factor of safety.
The operator cab, we decided to use 1-inch square tube that's 1/8 inch thick with 16 gauge flattened steel mesh. It's got 1.5 inch openings and a 1/4 inch plexiglass windshield. And we wanted to use a welded construction design on this. It fits in a 66 by 40 by 75 inch area with a door opening that's 44 inches wide. It weighs a total of 212 pounds. And after some research, we found that we were going to need a mechanical level feeder because the Spectra line that we spec'd out has a natural tendency to bunch instead of lay naturally along the spool.
So for the equipment mounting, we used FEA simulations to verify our designs. The first is the rope guide assembly. We tested this with the maximum load at the horizontal, and the maximum stresses are at the bottom of the mount of this, and that's also the location of the factor of safety. The second test that we did was with the maximum load at 70 degrees, and on this the stresses are at the top front of the plate, directly under the rollers, and that's that's also where the minimum factor of safety is. And for the motor stand, we used a distributed load at the top. And for this, the connection between the rising pieces and the top plate are the location for the maximum stresses and the minimum factor of safety.
All right, for the key interfaces, basically we had a couple goals in mind. Basically, we wanted to supply enough leeway and least amount of restriction possible for the other teams. So we decided basically we're going to over-engineer everything as of right now. Batteries, we need to reinforce the trailer. Decide to add a little extra reinforcement area, just in case we needed more batteries or if the size of the batteries changed for some reason. Also the controller, same situation there. And for the motor, we ended up building a motor stand. And what we did is we oversized the top plate for multiple mounting situations, and we also gave it a high factor of safety, just in case we needed to use a different motor. There was a few different situations where the disc was possibly mounted on it, so we just for different weight situations. For the winch team, they had their whole assembly, but as their size has changed a little bit here and there, so we did the same thing. We overestimated the reinforcement size that we needed to do on the trailer. Also, since we were in charge of the engine stand and the guidance system, we ended up varying the height of the engine stand and the feed system to match the winch, so there's no additional forces or anything. This is just us, so we depended everything on. So we designed the guide system. So we, like I said, we're the height dependent system, support system. So that's basically all the systems. We like we did the FAA analysis and whatnot. And the cab. Fortunately, the trailer, there wasn't any additional modifications that we needed for that. Just a couple of risks. We decided to go ahead and take this into consideration. Basically, the main issue here is our guide system could possibly jam. Everything else has low numbers. Basically, to fix that, you just simple inspection would have helped out. Cutter could fail. This is interesting, electric arcing. So we're going to go ahead and put a grounding rod in there. Flat tire, not too big a deal. Fire safety, we'll go ahead and do fire extinguishers. Weight distribution, so we use the FEA analysis to go ahead and do that. And hydraulic leaks, and then anchoring system as well. So to conclude this, we picked Supple rope cutter, designed a mobile support system to hold everything. And then also, since we designed the guide system, we went ahead and go ahead and support that as well. We designed the engine stand. We set high safety factors for flexibility for the other teams. And also, we ended up doing some hand calculations to back up the FEA analysis, just for a backup. And for recommendations for phase 3, we'll go ahead and move forwards. And if there's not too many more fluctuations in the other design, we can reduce the safety factors and the size of the equipment needed for cost and weight. Questions?